Okay, so we're continuing with section 5.1.2 notes. And we're going to get into examples 3 through 8 right now. They at first they're complicated until you understand how to do them. But it's pretty basic once you understand the rules. So in this case, we have 8 times 27 to the 2/3 power. So it's 8 times 27. And the best way to do this is to leave it as 8 times 27. You could kind of multiply 8 and 27 together and then deal with the 2/3 exponent. Um, and that's fine, but this method I'm showing you now is going to help you in the future when you leave it factored 8 times 27. So the first thing you want to do is just take 8, and your goal right now is to rewrite 8 as in its prime factorization, right? Almost all of these you'll be able to factor it into a prime factorization. For example, 8 is really 2 times 2 times 2, which is 2 cubed. And 27 is really 3 times 3 times 3, which is 3 cubed. So that's a goal that you want, because it's far easier to work with the exponent properties than to work with these integer 8 here and 2/3. So in this case here, 8 becomes 2/3, and then it's still raised to the 2/3 exponent right here. 27 becomes 3 to the third, which is still raised to the 2/3 exponent here. So we're not distributing 2/3. What we're doing is we're raising every factor in here to the 2/3 power. So 2 to the third is raised to the 2/3. 3 to the third is raised to the 2/3. Now we come into the properties of exponents. So we have a power raised to an exponent here. And the rule that we use is we multiply the exponents together. So 3 times 2/3 is going to simplify to 2. This becomes 2 squared. Over here, 3 times 2/3 simplifies to 2. Now we have 3 squared. And you can approach this either way. So you could just use the order of operations. 2 squared is 4. 3 squared is 9. 4 times 9 is 36. Or because they both have the same exponent here, you can multiply the 2 and the 3 together and get 6 and then square that. Okay. Number 4. Again, it looks pretty tricky. Don't let the fractional exponents overwhelm you or intimidate you. We're going to do this the same way. So instead of a product here, we have a quotient, 27/64. And in this case, we're going to approach it the same way. So we're going to write them in the prime factorization. And it doesn't always have to be the prime factorization. And I'll explain that in a second. 27 is really 3 cubed. 64 is several things. It's 8 times 8, but it's also 4 times 4 times 4, and it's also 2 times 2 times 2 times 2 times 2 times 2, 2 to the 6th. I personally like reducing it all the way down to 2 to the 6th. I chose to leave both of these to the third power because that can also be an advantage in many cases. For example, if you look here, this exponent of 3, when I multiplied to 2/3, those 3's are going to simplify and you're just left with 2. And a similar thing would happen if you had it, 2 to the 6th. So we rewrite them in the prime factorization, and then we apply the properties of exponents. So now it's 3 times 2/3, which is going to leave me with 2, right? 3 squared. And then 3 times 2/3, which is going to leave me with 2 again, 4 squared. Same thing as I explained on the last time. You could rewrite this as 3 squared is 9, 4 squared is 16, and then we're left with 9/16. You could, because again, they both have the same exponent, you could kind of remove the exponent for a second and rewrite it as the fraction 3/4 squared, which is also going to give you 9/16. So a couple steps here, we can kind of simplify this pretty quickly. 343 to the 2/3. Again, this can be written in a prime factorization. And for some of these, there is going to be an element of, testing or guess and check where you have to figure out, well, what's the prime base here that I can use? So this one's tricky, 343, it's 7 cubed, and then it's to the 2/3 power again. So we're going to apply that property of exponents and multiply 3 to 2/3. That leaves us with 2. So we're at 7 squared, which is 49. Next one, 81 to the negative 3/4. So this is now the first time we're dealing with a negative exponent. All right. And we'll address that. So what we have right now is we have 81, and what we're going to, again, try to rewrite this in the same base. So 81 is 9 squared, but it's also 3 times 3 times 3 times 3, 3 to the 4th. So now we're at 3 to the 4th, and then we're going to raise it to the negative 3/4 power. Apply that property. We're going to multiply the exponents. We end up with 3 to the negative 3rd power. Now remember, a negative exponent is repeated division. So this really means 1 divided by 3 times, or 1 divided by 3 times 3 times 3, which becomes 1/27. All right, number 7, negative 64 to the negative 2/3 power. So for this, I'm going to clarify it right now for us. There really should be a grouping symbol around this negative 64 here for it to be accurately represented. So I'm just clarifying that for us now. But again, we're going to apply the same procedures we've been. So we're going to take this number, negative 64, and we're going to rewrite it in a prime base. So here I'm using negative 4 cubed. Negative 4 times negative 4 is positive 16 times negative 4 is negative 64. You could take this to negative 2, could you? So that would be negative 2 to the 6 wouldn't work. So negative 4 cubed would work, because negative 2 to the 6th power is going to be positive 64 there. So I rewrite negative 64 as negative 4 cubed, again, to the negative 2/3 power. Apply this property. 3 times negative 2/3 is negative 2. So now I have negative 4 to the negative 2nd power. And at this point, you should address the negative exponent, right? So it's 1 divided by negative 4 squared. And then we'll square negative 4 and simplify straight to 1/16. Last one. 16 to the negative 3/2. Again, so this is a case where I'm taking 16 all the way down to a base of 2 instead of a base of 4 that we used earlier. So this is really 2 to the 4th, and then to the negative 3/2 power. I'm going to multiply these exponents, and then I'm going to be left with 2 to the negative 6th. So 2 to the negative 6th is really 1 divided by 2 6 times, which produces 1/64.